Welcome to the Chapter 7B study guide. The test will be easier than this. It will be representative as normal. It will have some multiple choice involved, but I took them off for the study guide so you could work it all the way through. So we will talk about each thing as we go. All right, first step is to talk about the conjugate. The conjugate is a takes the binomial and just switches the sign inside, not the outside. It's not going to be negative root 3. It's still root 3, but now it's a plus. It changes the operation to I. That's the conjugate. We use this when rationalizing either radical or imaginary denominators. Okay, now we found as we were working through this that the answer sheet in the back is not accurate. When I was working through these before I photocopied them, I did not double check the answers in the back. So it's not accurate. I apologize. We will talk about what the actual numbers should be. All right, so simplify 4 square root 16, fourth root of 16 and fourth root of 32. Well, we can rewrite these as the fourth root of 2 to the 4 and the fourth root of 2 to the 5. There's a couple of ways you can look at this. You could put them together into one fourth root. All right, that's going to end up with 1 over the fourth root of 2. I have 4 on top, 5 of them on the bottom. 4 of them will cross out, leaving 1 behind. And that's my fourth root of radical 2. Okay, so now we have to rationalize that. Come on. Okay, 1 over fourth root of radical 2. I've got to multiply this by the fourth root of 2 to the 3. I need a total of 4 in order to pull out the radical and get rid of that fourth root. So I have to do it all right, top and bottom. So since this is a 1, when I multiply it, my answer is going to be 4 radical 2 cubed. Okay, I'm going to need to make this bigger because I am all over the place. Sorry, not 4. Fourth root. Apologies. There it is. Sorry, I was looking for my erase. There it is. Okay, so that was supposed to be fourth root of 2 cubed over 2. The whole point of multiplying it by the fourth root of 2 cubed is that when I multiply them together, the square root or the fourth root would go away, and I would just have 2. So that actually is your final answer. There we go. Whoops. All right. We're making it bigger so I can get more on there. 1 minus 3i. Well, we have to multiply it by the conjugate of the denominator, 4 plus 2i, giving us 4 minus 2i. So we're going to multiply this by 4 minus 2i over 4 minus 2i. Now, the reason for that is that when I multiply these two binomials, I will get a difference of squares, which means 4 squared minus 2i squared, which is 4i squared. Now remember that I squared is a minus 1, so it's going to change my sign. Now my denominator, okay, remember this is a denominator, we'll talk about the numerator in a minute, will become 16 plus 4, or 20. No i's. That was the whole point. We're getting rid of the i's in the denominator. That's why we chose the conjugate, is in order to take care of that I, to eliminate the I by coming up with a difference of squares. All right, so now we have to look at the top. Okay, we're going to we got to FOIL this out, right? You've got two binomials. Okay, so I end up with 4. And I end up with minus 2i. And I end up with negative 3 times 4, so minus 12i. Negative 3i times 2i, negative 2i, is a positive 6i squared. Except remember, I squared makes this actually a negative. So I end up with 4 minus 6, which is negative 2. That negative, I'm going to be confused because it didn't come out nice. There we go. Negative 2, and then I have a minus 2i and a minus 12i, minus 14i, over, well, we said this whole bottom equaled 20. 16 plus 4, 20. Now, to simplify this, notice they're all even, which means I'm going to be able to factor out a 2 and get rid of that. Because I've got to pull out a 2, I now have negative 1 minus 7i over 2 times 10. Well, those go away, and I end up with this other part here as this section is my answer. Now, if it's a multiple choice, it might give you the answer that way. If it's a free response, I'm totally fine with your answer being minus 1 minus 7i over 10. Put a box around it and you're done. That's fine. But you might have to choose from standard form. And that just means minus 1 over 10 minus 7 over 10i. That's my standard form. So if you're having to come up with the answer by yourself, this one is fine. But in multiple choice, you might have this as an option. So you have to know and recognize that that's the same thing. Okay, so let's move on. All right. This is one of the ones that's wrong in the back sheet because it uses, I think it's 24 inside the numerator instead of 32. All right, so let's look at this. We've got 3 times the 4th root of 32. Well, 32 is 2 to the 5. And I have the 4th root of 162. Well, I need to factor that 162 because I've got to find out if I can simplify it. So I know I have 2, and then that's 81. Well, I know that 81 is 3 to the 4. Okay, so that means I have 2 times 3 to the 4. When I simplify this, the numerator, I have 3. I can bring out 4 of those as a single 2. So it's 3 times 2, but I have left 1 behind. So I still have a 4th root of 2. My denominator, that 3 right there, I can bring out. It's a 3 to the 4, 4th root. I can bring it out as a 3. So now I have 3, but I'm leaving behind this 2. So I then have 4th root of 2. Well, notice my answer is 2. I'm able to cross off a lot of this, and I end up with 2. Okay, simplify 3 minus 2i over 1 plus i. Again, conjugates. We're going to take the denominator and multiply it by its conjugate. So we get 1 minus I, the conjugate. This is why the very first question was making sure you understood what the conjugate was, because we were going to use it over and over again. All right, so the denominator becomes a difference of squares. That was the point. So I have 1 minus I squared. But I squared is negative 1. So I can cross this off and change this to a plus 1. All right, so really I end up with 1 plus 1. Hopefully we all know that's 2. If not, we need to kind of do a lot of remedial work in math. So 1 plus 1 is 2. Now I've got to FOIL the numerator. So I've got 3 minus 3i. And I've got negative 2i and a plus 2i squared. So negative 2i plus 2i squared. But I squared makes this negative. All right, so now I got to put this all together. I've got a 3 and a negative 2. So that's 1. And then these two added together give me negative 5i. This is all over. As we said, the denominator was 2. So again, free response, this is a sufficient answer. Multiple choice, you might see it in standard form. You need to know these are equal. All right, I think I'm out of... Whoa, what in heaven's name was that? There we go. All right, so now we go to the top of this page. We'll zoom in a bit. There we go. Simplify square root of 7/8. Well, the only thing I can do is I basically have to rationalize this, right? This becomes root 7 over the square root of 8. And now I rationalize. That's all you can do. To rationalize, I would multiply this. Well, first off, I have to recognize that 8 is... So we know that radical 8, that's 3 2's, right? It's 4 times 2, which becomes 2 root 2. So this is actually root 7 over 2 root 2. To rationalize this, I need to multiply by one more root 2. 2 times 7 is root 14. This portion becomes 2, so I have 2 times 2, which is 4. That's my final answer. You can't do anything with that one. You are done. Okay, moving on. Whoa, I don't like that. It annoys me when this does that. Okay. All right. Now, we have to solve this. First thing, we have to isolate that radical. So this is going to become 3 square root 2x minus 1. I'm putting the 2 on the other side by subtracting it. So this is equal to 3. Divide by 3. I have radical 2x minus 1 equals 1. 3 over 3. Okay, now I square both sides. I get 2x minus 1 equals 1. Because 1 squared is still 1. I add the 1. 2x equals, again, 1 plus 1 is 2. See how simple math is? I divide by 2. X equals 1. Now, on the test, I would advise you to check your answers. How do you do that? You're going to just simply plug them in. So let's take a look at what that means. I have 3 times radical. 2 times 1 is 2 minus 1 plus 2. Does that equal 5? That's our question. That's a weird looking question mark, but that was supposed to be a question mark. All right, so I subtract 2 from both sides. 3 radical. Well, actually, I don't even need to do that, so hang on. There we go. All right, so does it equal 5? So what we're going to do is focus on this and see if it equals 5. I have 3 times the square root of 2 minus 1 is 1. Well, 3 times root 1 is 1, so it's just 3. Is 3 plus 2 equal to 5? Well, when I was in school, yes, it was. So let's hope that's still true. Okay, 5 to the 4x minus 5. Well, the thing we need to notice is that 125 is 5 cubed. So you have to know some of these things, and I've been trying to tell you. You also have a spot on your card, you can, on your formula sheet, sorry, you can write some stuff down. So you could write that down, that 125 is 5 cubed. All right, so we rewrite this now so that both sides have a base of 5. This means I can set the exponents equal. Remember we said that 4 to the x equals 4 to the third, x is equal to 3. Okay, that becomes obvious when you see it that way. So now I can set 4x minus 5 equals 3. Okay, so these now, I can solve this. It's a simple equation with one variable. Easy peasy. Add 5 to both sides. Divide both sides by 4. X is 2. This is another one that the back had a different answer, I believe. Okay. All right. Now, this would notice nothing is in the variable is not inside a radical. So all we really need to do is isolate the y. So I'm going to subtract y root 3 together, get them all on one side. Right? So now I have 2 equals y root 5 minus y root 3. I can factor out the y. 2 equals y. What's left is going to be root 5 minus root 3. Anytime I have something multiplying my variable, I can strip it off by dividing. So now I have, and I'm going to divide this side by it. Root 2, I'm so silly, root 5 minus root 3. Okay, now what I have is y equals 2 over, I'm going to have to rationalize this denominator. So I'm going to multiply it by its conjugate. I know you're going to get really tired of hearing that term. Conjugate, conjugate. All right, but it's kind of a miracle thing because it gets rid of a lot of stuff and simplifies things for me. Okay, so now this is equal to, well, 2 multiplied in, it's distributed in here, becomes, well, you know what? Okay, I found it. It did some kind of weird flipping thing. Anyway, okay. So now my denominator is going to be root 5 squared is 5 minus root 3 squared, which is 3. My numerator, I'm going to leave the top 2, because notice my denominator is going to be 2. So I'm going to be able to cross those off, so that my final answer is merely root 5 plus root 3. Okay, let's get this all on the screen. There we go. All right. Now, notice I have square root of 2x minus 1 twice. So I don't have to actually solve for this right now. First thing I'm going to do is get these together. So I'm going to subtract 3 times 2x minus 1 from both sides. Okay, and that's going to give me 2x minus 1. Well, to get my balance going, I'm going to take this 3 and move it over to the other side by subtracting. So I have 1 minus 3 is negative 2. Okay, we should already start to notice there's a problem here. Square root cannot equal a negative number. This is going to be a no solution. Different ways to figure it out. You might have to, what's going to happen if you continue to work this problem, you're going to get a number and then you plug it back in and it's not going to work because there is no solution. All right, so if you squared both sides, then the negative goes away and you have a problem. You square root it, you're going to get a positive 1, not a negative 1. That's why it doesn't work. You square both sides, you're going to end up with 2x minus 1 equals 1. You're going to add 1, 2x equals 2. Divide by 2, x equals 1. You plug that back in. It's not going to work. So this is a no solution. All right. Oh, we're done with this page. Okay, next page. What, all right. Oh, whoa. Happen. I don't know where my screen went. I'm going to pause this and find out where everything went, and then I'll come back. What? Okay, here we are. Now, we're moving on to number 11. 8 to the x minus 27 equals 5. So first thing I'm going to do is move that over. So I'm getting my 8 to the x all by itself. So 27 times 5 is 32. All right, well, we know that 8 is 2 cubed, and 32 is 2 to the 5th. Same base, I can set my exponents equal. Divide both sides by 3. And I've got my answer. It's that simple. This one was not hard at all. You just have to remember to get the bases to be the same so I can set the exponents equal. All right, here, since that's a plus, that's a little more complex. Okay, so I'm going to change this into 4 to the 2x. Okay, that's going to become a base 2. I'm going to change this into a base 2. So everything's in base 2. So this becomes 2 squared. 4 is 2 squared. To the 2x, those to the 2 2's become 4x. So notice I have 2 to the 4x's. 8 is 2 to the 3 times 3, or not times 3, to the 3. So this is going to actually end up 2 to the 9, 3 times 3. All right, now, because it's added, I can't do anything with this at this point, except for to notice that those are identical. So what that means is I have 2 to the 4x plus 2 to the 4x. I have 2 to the 4x's. And that's equal to my 2 to the 9. All right, well, 2 to the 4x times 2 to the 1 is going to be 2 to the 4x plus 1. Now I can set my exponents equal. I'm going to subtract 1 from both sides, divide by 4. All right, we can double check this. If x is 2, I have 4 to the 4. Plus, if x is 2, I have 2 to the 2 times 4 is 8. All right. Does that equal 8 to the 3? You can put that all in your calculator. Sorry. You put that in your calculator and find out if these are all true. Okay? There's not a simple way to do it. You just have to figure out what these numbers are. All right. Moving along. There we are. Square root of 3, 2y plus 1 plus 5 equals 2. Okay. Sorry, cube root. I think I said square root. Cube root. So we've got to isolate the cube root. By subtracting 5 from both sides. It's okay that this equals negative because it's a cube root, which is odd, not an even root. Second root, square root, fourth root, sixth root, those can't equal negatives, but odd roots can. So this is fine. All right, so now I have to cube both sides. 2y plus 1 is equal to, well, negative 3 cubed. 3 cubed is 27, so it's negative 27. I'm going to subtract 1 from both sides. 2y equals 28, sorry, negative 28. Divide by 2, y equals negative 14. Okay. It's negative 28. I'm just checking it real quick. I plug it back into the first. I've got negative 28 plus 1, cube root of. Oh, that plus 1 looks terrible. Who can tell that's a plus? Plus 1. There we go. It's just hard to write on these screens. Plus 5. Does that equal 2? Well, negative 28 plus 1 is negative 27. Cube root of negative 27 is negative 3. Plus 5, that does indeed equal 2. So, check. It did work. Okay. All right, now, notice that what's inside the square root is different for both of these radicals. So I'm going to have to end up squaring this thing twice. So I get 1 on the other side. You want your most complex to be by itself. So I want this guy isolated. So I'm going to subtract the 2 root x. But notice this still has a negative on it, so I'm going to have to get that over there too by multiplying through by negative 1. So I'm going to end up with 3x plus 1 equals. Now that negative 1 means I'm going to flip all my signs. So I've got 2 root x minus 1. Had to flip my signs. All right, now I'm going to square both sides. And that's going to get the 3x plus 1 out of the radical. But I have to FOIL the other side, so I'm still going to have a radical. When I square this, I end up with 4x. That's this term squared. And then I end up with twice the 2 combined, so negative 1 times 2 root x. It's just 2 root x twice. So 2 times 2 is 4. So this is just 4 root x. And then the final term squared, plus 1. All right. Now I have to go through and isolate the radical x. So I'm going to subtract the 4x, and I'm going to subtract the 1. So I end up with negative x, and that goes completely away. Okay, and that goes away, and those go away. And so this is equal to negative 4 root x. Well, I'm going to move this negative. I actually don't even have to do that. I'm just going to square, and it's going to take care of that. Square both sides, and I have x equals negative 4 squared is 16. Root x is x. Okay, now I've got to subtract the x. Yeah, okay. 16x minus x is 15x, so 0 is equal to 15x, which means x equals 0. Okay, I spotted a problem I had. So let's take a look at what my problem was. Okay, notice I went from minus 1 to plus 1. Gee, I'm magical. No, that actually is right because it's plus the square. So it is plus 1. There's still something else wrong, so I'm looking for it. So I'll be back in a second to explain it. Okay, found it. Sorry, I just didn't want to take up your time looking for it. All right, what I did was, notice when I went from here, I squared it, I lost it, but it would have been x squared. I'm so silly. So this then, I'm going to erase because this is not accurate. Okay, why are you not erasing? Okay, I'm going to pause you. Okay, I got rid of the stuff that was a mistake. And somehow that wrote a line instead. There we go. All right, so since that's supposed to be x squared, I end up with x squared minus 16x equals 0. All right, so I factor out an x minus 16. So x is 0 or 16. We know that. All right, if I plug them in, I believe the 0 is extraneous. I don't know, one of them is extraneous, so let's try it. All right, so 2 times 0 is 0. Okay, what I'm going to do is change my color of pen to blue so you can see what I'm doing. With all this other writing, it's hard. I have 2 times 0 is 0 minus the square root of 0 plus 1. Square root of 1 is 1, so it's minus 1, equals 1. Nope, that doesn't work, does it? 0 minus 1 is negative 1, not 1. So 0 does not work. So we cross out the 0, and our answer is x equals 16. You can try that one, but it will work. Let's see. I'll change to red so you can see that one. 2 times a square. Aha, there we are. Okay, so what do we say? 2 times 4 is 8. So we have 8 minus 3 times 16. Oh, that's easy. That's 48. Plus 1 is 49. Square root of 49 is 7. So 8 minus 7 equals 1. Yes, it does. Woohoo. So that's my answer. Okay. Let's move over here to number 15. All right. So what we're going to do is take this and multiply, raise it to the power of the reciprocal of the power I have. So that means this one is also going to have to go to 3 to the 2. All right, so this becomes 1, leaving me with just 3x minus 5. But I can rewrite the 4 as the square root of 4 because of the 2, and then cube that, because the square root of 4 is 2. I know that. So I have 2 cubed, which is 8. So if I add 5, I have 3x equals 13x equals 13 over 3. Apologies. That should have been plus or minus root 4. When you take the square root, you got to do a plus or minus. And since it's cubed, not an even power, it's going to keep the plus or minus. So this is plus or minus. So when the plus, I got 13. If it's a minus 8, I add 5. I have a minus 3. So negative 8 plus 5 is minus 3. Well, if I divide that by 3, I'm going to have a negative 1. So I also have negative 1 as an answer. So there's 2 answers. I apologize. All righty. 2 different radicals, so we have to do it twice. So I'm going to raise this to a power. I have to include that first 2 in the power. So I have 3x plus 1 equals 4 times 2x minus 1. Well, this becomes 8x minus 4. Subtract the 3x. I like to go to the larger. And I'm therefore going to add 4. So I have 5 equals 8x minus 3x is 5x. Divided by 5x is 1. Okay, I'm going to check it real quick. 1 plus 1 is, 1 times 3 is 3, plus 1 is 4. That's this bit. Square root of 4 is 2. So I have 2 equals, so now I have 2 minus 1, right here, 2 minus 1, if x is 1. 2 minus 1 gives me 1, square root of 1 is 1, times 2 is 2, 2 equals 2. Yes, x equals 1 works. Okay. Which of the following functions might have a graph like the following? Okay, so here you are given some options. First off, looking at this graph, we know that a is greater than 0. Remember, we have, you might want to write this on your, make sure it's on your formula sheet. Square root of x minus h plus k. So I know a is greater than 0 because it's arching upwards. If it was arching downwards, a would be negative. So that means this number out here has to be positive. They all are. Okay, notice that vertically it's shifted downwards. So that means I'm going to be subtracting k, which means that these must be one of those two answers. It cannot be a plus 2. All right, notice it is shifted backwards, and remember the h flips, so this has got to be not a minus, but actually a plus. So it's got to be B. Whoops. There we go. Next. 16. Square root of 16 is 4, so 2 times 4 is 8. Oops. Nope, minus 3. Whoa. Page. Yay. Okay, without using a graphing calculator. Graph f of x equals negative 3 minus, square root of x minus 3 minus 2. All right, so we know that h is 3 and k is negative 2. We know that the beginning point, the vertex, is hk. So my vertex is going to be 3, negative 2. Okay, so positive 3, negative 2. I know I'm starting right here. Okay? At negative 3 means it's not a standard curve. So normally a standard curve would go here. 2, 3, 4, there. And yours is not. Yours is being multiplied by negative 3. So it's flipping upside down. So instead of going here, which if it was a negative 1, 3 times 1 is negative. There we go. So that's my first actual point. I'm going to go over that in blue. Okay. Then the next point would have been here, should it be a standard, but it is multiplied by 3. 2 times 3 is 6. So now I have to go 6. 1, 2. That's my normal. 3, 4, 5, 6. So I'm all the way down there. Okay. So what you can do is write yourself a little XY chart. All right. Now this is a little more complicated. What you want is x minus 3, that's what I have inside my radical, has to equal 0. Well, x is going to have to be 3 for that to happen. If x is 0, if what's inside is 0, square root is 0, negative 3 goes away because it's times 0, I'm left with just my negative 2. And sure enough, that is my vertex. All right, now I want that to be 1, the x minus 3 to be 1. So x is going to have to be 4. Square root of 4 is 2. 2 times negative 3 is negative 6. Minus 2 is negative 8. Okay. I'm sorry, x is not 4. I want it. Yeah, it is. Right, x is 4. I should have, why do I have negative 5? Okay, I must have been all messed up in my head. So let's see. That is 4, then this is 1. Yes, that's what I was. 1 times negative 3 is negative 3, plus negative 2 is negative 5. Boom, there we go. And let's get rid of my silly negative 8. We're going to change that. I'm going to fix up my 2 and change that to a negative 5. Now we want it to equal 4. Minus 3, so that's a 7. 7 minus 3 is 4. Square root of 4 is 2. 2 times negative, this is going to be my negative 8, by the way. 2 times negative 3 is negative 6. Add a negative 2. Here's my negative 8. That is why at 7, I got negative 8 down here. So those are my points that I would expect to see whatever's going to be on your graph. If it wasn't shifted over by 3, then you would probably need to put what would make a 9. Okay, this is, I know, a lot. Your test will be smaller than this and easier than this. Just be of good cheer. All right. This you can put in your calculator. What you're going to do is graph each side. So that for the first term, my first equation is 3 square root x minus 2 plus 2. My second equation is 2 root x minus 1 plus 1. You graph those and you go find the intersection. If you have your calculator, your TI-84 calculator, 83 will work the same. You have to find these, the intersection. You do a calc 5, I believe. Anyway, under the graphing screen, there is like 5 buttons. There's graph, which is the furthest one to the right. The one right before it, that I believe is calc or trace. Now, the button may say trace with calc above. Anyway, you put that button and you want intersect because you're looking for where these two lines will intersect. I think it's number 5. Anyway, then what you're going to do is use your arrow buttons in order to move the little flashy thing until it sits right on top of... Sorry, I apologize. Hang on. That came off pause. So that it sits right on top of the spot where your intersection is. And then you just hit the enter button 3 times. And that'll take you through this scroll of 3 different points. But don't worry about that. 3 times, and up will pop at the bottom of the screen what your x and y value is for the intersection. Okay? So you're going to do that on this one as well. All right, so y1 would equal negative. Remember, this is negative, not subtraction. Different button on your calculator. Plus 4. You can do to the 1/2. Plus 6. When you do the plus 6, you have to make sure you step out. Now, what might be easier for you, there it is, would be instead of all of this, just put it inside of a radical. Right, so I know that this is a radical. So it's minus square root x plus 4. Wow. X plus 4 plus 6. That is what you're actually putting in your calculator. Okay, and y2, I would do the exact same thing. Equals 5 radical x minus 1. Then step outside. You have to make sure that's outside. Then you're not putting the square root of x minus 1 minus 1. It has to be x minus 1, right arrow, minus 1. All right, now we're just moving over one more here. Whoops. Okay, describe h and k. Well, h is 1. And k is 2. All it is. H is your vertical shift. So you go, horizontal shift. H is your horizontal shift, so you shifted 1 unit in the x direction. K is your vertical shift, and you shifted 2 units in the y direction. And you're done. Okay, so that should be the finish.